Now let's turn our attention to part B of the same question. Can I find points on the curve C where I get the tangent line being horizontal or a tangent line that's vertical? Now I can probably go ahead and look at the picture to see that there are probably some spots that are pretty easy to spot a horizontal or a vertical tangent line. A horizontal tangent line might exist right up here at this peak, all the way down here near this valley, and maybe a vertical one could be thought of as kind of almost existing like this y-axis, attaching maybe right here near the origin. If I want to be sure of those, I'll go ahead and just check what the derivative definitely tells me. So I know that in order to get a horizontal tangent line, so I'll say to get a horizontal tangent, we need dy dx, which was equal to, and if I scroll back to the previous problem, I can look, that was 3t squared minus 9 over 2t. 3t squared minus 9 over 2t, I would need that to come out equal to 0. Of course, that implies that 3t squared minus 9 would need to be equal to 0, and that implies that t squared would have to be equal to 3, which gives me that t has to be equal to plus or minus 3. Now I'm interested in finding not just values of t, but the points where this happens. So I can say that this corresponds to the points, and I can see that if I plug in these values for t into my original equations for x and y, I should be able to determine the actual xy coordinates of a point. So really quickly down here, I'm just going to rewrite down that x was equal to t squared and y was equal to t cubed minus 9t. So notice that in both instances, my points are going to have an x-coordinate of 3. The y-coordinate, though, might be a little bit different. Let's see. If I take my square root of 3 and I cube it, that's going to get me 3 square roots of 3 minus 9 square roots of 3 is minus 6 square roots of 3. If I plug in a negative square root of 3, I'm going to get negative 3 root 3's plus 9 root 3's, and I'm going to get 6 root 3's. Notice that this second point is above the first point, and that actually corresponds perfectly to the two spots in the picture where we thought we would have horizontal tangents. To get vertical tangents, we need something different. So I'll say, to get a vertical tangent, we need dx dt to be equal to 0 and dy dt to not equal 0, right? We need the bottom of this fraction to turn into 0, but not the top. So clearly, we can see that dx dt is equal to 0 whenever 2t is equal to 0, and that happens only at the time when t is 0. But clearly, if t is equal to 0, then this numerator is not going to turn into 0. So we have that at the point t is equal to 0, or at the time t is equal to 0, we get a vertical tangent line. So this corresponds to the point, and let's see, I would have 0 in for t, that gets me 0 for x, and also 0 for y. If I look at the picture at 0, 0, I actually do see that's exactly where I get a vertical tangent line. So this is how I can use this idea of the derivative to help find these horizontal and vertical tangents. In the next video, we'll take a look at part C and try to understand how we can actually determine the concavity of a curve like this.